The seventh assumption for the Gauss-Markov list is no perfect collinearity among our predictors. So that means, put in the most succinct way, that we cannot have two predictors that are perfectly correlated. If we do have two predictors that are perfectly correlated, we run into problems. So let me just show you what happens when we have perfect collinearity. So here's a situation in which we have imperfect collinearity. Oh, well, we have perfect collinearity. And why is that? Because I create my first x1, and it's a random normal variable. My x2 is essentially a replicate of x1. Then even if I just add some constant, let's say 4, and I run this, it is still going to be collinear. So let's just look at these results. In the first instance where I didn't add a constant, look at what happens. I get no estimates for x2, and the reason for it is x2 is perfectly confounded with x1. And you'll also see here for the coefficients, 1 is not defined because of singularities. And the reason why they're singular is that there's a perfect correlation in the off diagonal. So I'm going to show you this in a second. But first, just to show you what happens when we add a constant, we still get the same results. All right, now what happens now if we do this? If we say core of x1 and x2, it's 1.0. So our two predictors are perfectly correlated. Now, how does this happen? Well, usually it happens by oversight. So the investigator collects some data and doesn't realize that the variables are going to be perfectly correlated, or the data analyst doesn't know the content area, recodes a variable, or has a data set where there are two variables where one is a perfect translation, or it has been transformed so that it is perfectly correlated. The only way to resolve this is to identify which of the variables is relevant to your model and transformed appropriately or whatever, and use that one and get rid of the other one. So perfect collinearity is a problem only in that you get one parameter estimate. So the easy way to deal with that is to sort through your data, make sure every variable is unique or reasonably unique and contributes unique variance to predicting y. We have two more Gauss-Markov assumptions. These are going to be pretty quick, so I know you've got a lot of videos for these assumptions, but these next two are going to be short, so stay tuned for the last two.